All right, my friends, welcome back to Build Science
201.
We're talking vapor today, vapor control. And Steve, we're talking perspective. What is your perspective on vapor?
Well, it's funny you should ask because a lot of people think of vapor as a liability, but I'm in the asset camp.
Ooh, we got a good episode today. Vapor perspective, let's get going.
Build Science 201 is sponsored by Anderson Windows and Doors, Huber Engineered Woods, and Proseco.
Hi there, I'm Matt Reisinger, and today I want to share how zip system building enclosures are truly transforming the future and frankly the present day of construction. The zip system portfolio streamlines the installation of critical components like the weather-resistive barrier and air barrier. Plus with zip system R-sheathing, you get continuous installation for wall assemblies all in one efficient package. These products aren't just about ease of installation, however. They help builders meet vital performance goals. Think lower blower door scores and even Energy Star certification. Achieving higher efficiency has never been easier. What are one of the standout features of zip system, you might ask? The tape seams create a tight barrier against air leakage, resulting in a more energy efficient building enclosure. I gotta tell you, this is a game changer for the comfort of the homes that we build, and I absolutely love this feature about Zip, is that it's not just waterproof, but it's naturally very airtight as well. Zip system has fundamentally changed the way homes are being built today, and the best part, these innovative products are available nationwide. Just ask your local lumberyard. And here's some exciting news. There's a rebate offer for Zip System products. Just use the link in the description to learn more. Let's build better together. Check out those rebates and make the smart choice with Zip System today. All right, Steve, where do we start on this episode?
Well, we start with a plan, right? Because if I want to look at vapor as an asset, then I have to create a plan that allows for drying.
Yep.
And if I consider it a potential liability, I also want to have a plan to make sure I don't get myself in trouble.
Makes sense. So that's what we're showing here is a planning meeting, I suspect.
That's what we're showing. This is a pre-construction meeting. These are my good friends, Shoreline Builders. You know, I always commend Jim. He'll bring in all his guys. We'll sit down. I'll take the wall sections. We'll strip a bunch of the notes off, and we'll talk about what we want to do with the project. And we'll talk water management, all of them, but also vapor and what we want to do. So all these guys, when they're putting that bead of sealant or taping something, they understand what they're doing. That's
really smart. And what they're controlling by building this wall, right?
Yeah.
What are we trying to do here with this assembly?
And you know what I find the most interesting for especially the architects out there? You can learn a lot from sitting around a table of these guys.
Well, that's for sure.
Right? You ask a couple questions and they're like, well, if you did it this way instead of that way, and then you don't end up with your drawings in the trash can saying, that's just a whole bunch of dumb ideas.
That's a great point.
Because we're actually working with them.
Yeah, that's great.
Liability. We'll start there. Yeah, so this is what you don't want to happen.
This was a photo that I took on a 20-year-old house. Vapor barrier in the wrong spot where we should not have had a barrier. We should not have had anything on that Texas house. This was built in Austin, Texas about 20 years ago. If anything, the paint and the drywall would act as a bit of a retarder. And that's really all we need or want in the South.
And you know, I say it all the time, you can learn a lot from when you're taking apart buildings. If we blow that up, look what's happening around the outlet there.
Yep.
Right? That air leakage through there, getting stuck behind that impermeable membrane, the poly, we're creating a mold farm.
Yeah.
Now, for you homeowners out there, that's probably not an outlet you want with a crib in front of it.
Mm-hmm.
Right?
That's a great point. Yeah.
So those are the things that you should be concerned about. That's the reality of a photo like that.
That's a great point.
Liability. It's not only relegated to walls, roofs. If you don't have proper ventilation systems in, if you don't have a proper plan, that is your result.
This is a cold climate. These are roof photos. We're looking up at the roof. And the issue here was that we didn't have adequate ventilation to get rid of moisture that was accumulating in those cavities.
You can see the outline of the vent, right? But notice, the minute you introduce blocking, you get a lot more mold than you do in that one.
Yeah.
Right?
Because that other bay did a better job of ventilating, of moving air through that cavity. Steve, let's talk about this house. I've coined this monopoly framing, but it really comes back to the old master, Joe Stiebrick. We've heard us talk about him before. He wrote an article in buildingscience.com called The Perfect Wall. The idea is, could you build a house, could you build a wall that would last 500 years using typical residential American materials? And the perfect wall is also the perfect roof, is the perfect slab or bottom to the house. I took that concept and built this house in 2014 using his methods. I've kind of changed the name to Monopoly framing because it looks like a Monopoly piece to me. But the whole idea is that this construction, Steve, is standard wood framing. We've got 2x4s on 16-inch on centers. We've got a wood sheathing on the outside. And then in the whole exterior of the house, continuous from the slab all the way to the ridge, we've got a peel and stick material. Now that peel and stick, as we're talking about vapor here, is a vapor barrier. It's a zero perm product, which works great in Texas. And Joe said at the time that he wrote this article that this same house could be built anywhere in the US, frankly. You could build a house with the same concept in Alaska. The only thing you might do differently is add, or that you would do differently, is add more insulation if you were in a much colder climate. So let's go to the next image, Steve, if you would. What we did was, on top of that full peel and stick vapor barrier on the outside, we did 2 layers of 1.5-inch insulations for 3 inches of polyiso on the walls, and then 2 layers of 3-inch polyiso to get 6 inches on the roof. That met our insulation codes for climate zone 2 at that time. And now we've got a full insulation on the outside of the house. It's outsolation. On the inside of this house, if you'll scroll to the next slide, Steve, we didn't put any insulation. We didn't even put any sheetrock, frankly, on the inside of the house. What you're seeing there is framing that we ended up just whitewashing. Now, we did run the wires in conduit where they showed. We kind of hid the ductwork behind some shiplapped walls that we added some wood shiplap. But in effect, there's no drywall on the inside of the house. There's also no inside insulation. So now, when it comes to vapor, that vapor is stopped at the outside of the house. And any vapor that's happening inside the house, from us breathing, from us cooking, from any other moisture sources inside the house, they can all dry to the inside. The whole concept behind this is just like your dining room table. You know, how long will your dining room table last if it's inside your dining room? A long, long time. And so we're treating our wood framing, that structure of the house, the same as we treat our dining room table, which is going to last a long time. So 500 years is what Joe says this house would last, and I believe it. You know, if we did get a window that leaked, we've of course taken our best practices for water management. The other nice thing about this is you would actually see that leak if a leak were to occur. And it's also would leak into real wood that really is not very prone to having mold or other issues as long as it can dry if it gets wet, right? Yeah. So it's a pretty interesting concept. Now, if you go to the next house, I've built several houses since then with the same type of concept, including my own house, where I built my house with Monopoly framing. And so I used this time zip system sheathing on my outside, and you'll notice that my wall sheathing actually touches my roof sheathing, and everything is continuous. Now, if you think about zip system sheathing, there is a vapor retarder in that assembly. It retards vapor flow. It's not quite zero perm, though, like that peel and stick was, so there could be some drying through zip system sheathing and the tape that's on the outside of the house. Mm-hmm. And then I added exterior insulation on the whole outside of my house. I did it on my roof, on my walls, everywhere, and I did it in a couple inches. But on my house, I wanted a more traditional looking inside, so I used some rock wool insulation inside my house, and then I used traditional sheetrock. But when it comes to vapor, I don't have anything stopping that vapor from drying to the inside of my house. And on the outside, the zip is my water and my air control layer on this house. So once I did that, the only thing I had to deal with when it came to vapor is I used an energy recovery ventilator, an ERV, to ventilate out of humid and stinky areas of my house, just like you might use a exhaust fan on a traditionally built house. But it's made for an incredibly durable and incredibly comfortable. in a house that manages vapor such that I'm not going to have any problems with this house.
All right, Matt, you got a perfect house. I have a perfect house hybrid.
Oh, all right. Let's hear about it.
All right. So we have this one picture here. Let's blow this up a little. Nice building section image. So we have a 2x6 wall on both sides, but also notice here we did floor trusses and we hung them off the outside here. They were 14 inches. So now this is climate zone 5, so we're up there in the Northeast.
Much colder.
And we have our insulation package there, and then in the in that 2x6 wall, we have our R21 package there. We were probably somewhere around R77 in this house.
Holy cow.
Now, this is a passive house. It's only 800 feet. This was before the rules got modified in passive house.
Is that called a Larson truss?
It is a form of a Larson truss, very much so. But the beauty of down below here is that we have the ability to dry on both sides of that line,
That's really
of our
nice.
air barrier.
Yep.
Right? But the thing about this house, and the reason I call it a hybrid is, you can see here, this is that section there, and we just put up board sheathing, so we have the ability to dry. That's covered with a felt paper.
Okay.
So again, we have that ability to dry to the outside.
And filled with like cellulose or something?
And it's actually filled with a blown rock wool.
Oh, neat.
And the boards actually, the reason that they were such a good choice for this is the fact that we could take off this board and we could take off that board and we can do lifts in the insulation. So our quality control is very high on this project.
So blown mineral wool back there to 14 inches deep. That's pretty serious.
Yeah, that's alone is 56.
That's a lot.
R56. But notice up here, we have polyisocyanurate. Now there we did 2 layers, you can see, and we staggered the joints.
Yep.
And that is impermeable. So we don't have the ability to dry out anymore. We can only dry to the inside. So hence the hybrid name on that.
Got it.
All right, so this is a retrofit project, Matt. This is that one that we saw at the beginning that we called it a liability with all the mold in the rafters. So this is how we solved it. We actually resheathed the roof. We pulled up all the old sheathing and we resheathed it. But then on the outside, we added 2x4s to the outside of the roof there.
Okay.
And then you can see, because we wanted to still use the same box soffit and the ventilation system, we just enhanced that ventilation to the top side of the sheathing. And then we resheathed this, so now our vent space is that 1.5-inch vent space all the way up the roof. So inside the cavity here, we can put a bunch of insulation.
That's really smart. So instead of using a baffle, you know, a lot of times you'll see corrugated plastic cardboard baffles that are kind of U-shaped up against the deck. You've inverted that and brought that ventilation to the top side of the deck, which I love that idea.
Yeah. And the homeowner had a strong aversion to the vent baffles because that's what got him in trouble the first time.
Makes sense.
Yeah. So this is just a real simple photo, right? I always use the term vent until you can't, right? I like to do vented roofs. I know down south here, that's where you start to put it in question. But at least in our climate zone, say climate zone 4 and above, it's somewhat of a no-brainer for me.
Yeah, I mean, it's a more forgiving roof assembly. If there's ever any leakage that happens in there, there's plenty of airflow to dry it out. And honestly, it ends up being a less costly assembly, I would say, in general.
Yeah, in general, because for one, you get to use the cheapest insulation in the attic, which is a blown-in cellulose, or it could be a mineral fiber.
Yeah.
But it's a real easy application. And the thing that I really like about it is you can see it here. You can actually use the ventilation system to be a highlighted architectural aesthetic.
That's really cool. So just gapping those 1x boards that you used on the soffit, and those gaps combined for quite a bit of ventilation space.
Yeah. So, and it's, that's probably overly ventilated per code.
Yeah, that's great.
We always talk about cost, right? One of the beauties of ventilating a system here is the fact that we make these boards more stable by putting them in a condition where you're seeing the same conditions on all 6 sides of the board. So this is a project, you can see we use rough cut pine. Now, some people would say, if I just told you we were using rough cut pine, you'd be like, oh, what are you, Are you serious? That thing's going to warp, it's going to cup, it's going to twist, all of these things. But when you think about how did we dry boards before we had kilns, right? We put them on a series of 6, and the boards became nice and stable, and they dried out.
Yeah.
All we did is use the lumber yard technology, and we applied it to the wall here.
I like it.
But that also allows us to use a cheaper or less expensive material.
And an expensive cladding compared to a more precious material.
So this is a blow up. This is really close. And you've actually been to this house. This is our Riverside project. And you can see here, this is an open joint, vertical joint. So air can get in there. And you can see here, it's vented there. And then on these, there you can see there's little triangular spaces. And I've actually done some testing on that, pouring water through. But air and water can move in that direction. And so it's just a real close-up. And the other thing of note is this is not only a UV protected barrier on the wall system, but it's pretty much vapor open. I shouldn't use the word barrier, but it's a vapor open membrane that is UV protected there.
Cool.
So it's a system that can dry to the outside. It has a lot of drying capacity, and it has really good draining capacity.
That's great.
And you know, this photo I put up because a lot of times people say, you know, high performance homes or homes that are kind of tilting towards performance, well, they don't always look so good, right? So here we did an open cedar rafter tail.
Beautiful.
And it looks good. We have some nice cedar boards here. And the beauty is, this is a vented roof because we have a core vent in each one of these slots.
That's really cool.
With a little shadow board.
If you're not familiar with core vent, it's a looks like corrugated cardboard, but it's made from plastic. And if you can think of cardboard that's stacked together, if you look at the side profile of a cut piece of cardboard, you can see there's channels in there. There's kind of a S-shaped cardboard with 2 pieces of paper. Same thing except made out of plastic. Stack those together and now you've got a material that doesn't compress very easily, but if you look through it, you can see daylight through it. So it's often used for soffit type venting applications. I've used it a bunch over the years and I like it. You can also make it yourself just by getting the material.
And so this is a slightly different system here. You can see we did a blown cellulose dense packed 2x12 rafter cavity. This is a passive house inspired house. It would have made it. The homeowners just didn't want to pursue the plaque on the wall. But what you see here is the ability to vent on the top side of that roof sheathing. So we have that 2x4 that comes out on the flat. That extends all the way up the roof. And then on the high side, it's a contemporary single slope roof. So on the high side, it extends beyond the wall. And then we tee in a 2x4 there for support so it doesn't want to bend down. And then you can see there's an insect screen all across here. So then we'll just put in our soffit boards and we have a total vented roof assembly.
Smart.
With a dense pack cellulose rafter assembly.
I like that.
If you remember, Matt, you've been out here a number of times. This is original Build Show Build House.
Yep.
Right? Built this, Jake was the builder. I designed it. Now, one of the things about this is these roofs were 1 in 12.
Low pitch.
Very low pitch.
You don't think of metal roof typically as being able to be done on that low of a pitch.
Right. And I've always heard, oh, you don't ever want to vent a roof until it's a 3 in 12. Right? But remember how we started out. I like to think of assets, not liabilities. So when people say, oh, you can't do that, the question is, well, is there a way to do it? And is there a project where maybe that makes sense to do? Now, this isn't for every project. Don't go out and all your 1 in 12s and 2 in 12 start venting them. The reason I thought this was successful is it's only 18 feet across here. We have full ventilation happening along the rake going in. We have this 10-foot overhang that's giving us air, and then on the other side, all along the rake. So we are inducing an immense amount of ventilated air into the system. Right, and you can see up here, it is vented, so we have a detail here where it kicks that air back out. And this one in 12, same thing, fully vented. And the reason we know it works, we had our good friend Peter Yost came down with his whole bag of goodies, and we actually tested it. He blew some smoke in, 28 seconds later, smoke came out.
Wow.
Yeah, it worked very fast. He thinks that the low emissivity of the black roof helps induce some of that airflow too.
Speeds that flow.
So there's a bunch of little things here, I think, that make this house, you know, a very successful. And you can see here, we used that top layer ventilation system so we could pack our insulation right up against this roof sheathing here. So you can see we have those holes where the air can go up and then go up the roof. And that's what you're seeing here, right?
That's cool.
Having that come up and go up there, as well as you can get air inside the roof.
So in effect, it's a double sheave, double roof with ventilation on the underside of the roof.
Yes.
And the metal is right on top of the deck.
And lastly, we'll finish with this one.
What are we seeing here? Explain it just to make sure everybody understands. So
when I was doing a little walking tour in our different country just north of us. But you know, we talk about control layers, we talk about the rules and laws of Mother Nature. The one concern that you want to be a little bit cognizant of is that if I solve for, say, water management, like here, right? I have a nice piece of glass here. There's an entry door and stuff down below. Hey, we've done everything that we talked about in water management. But what we failed to recognize is the water that falls and hits this bounces back up on the wall and creates a vapor moisture problem, right? So you don't want to solve a problem, but create a problem with that solution. So be very careful that you don't stop at water management and you said, hey, okay, we tilted that. Did that create a problem?
That's good. Steve, if I could summarize, you know, if we really get water and air management correct on our jobs, vapor kind of takes care of itself. And so when we think about vapor, we need to be, number one, cautious about where we use a barrier. We want to use barriers where houses meet soil. We want to use barriers where there might be running or standing water, places like that. The rest of the house, almost everywhere in the U.S., really including Texas, we want to think about having some permeability of our building materials and making sure that if there is some amount of moisture in a cavity, that it can get out. And ultimately, I've heard Joe Stiebrick, kind of the godfather of building science, say, and I think you would agree with this, we've all seen thousands of water issues. We've seen lots of air issues, not quite as many as water, but I've only seen a few dozen vapor issues in my career. Not that you can't have them, they certainly can happen, but if we get water and air right, this is the least important of our worries on a house.
Yeah, and it's when it does become a problem, vapor, it kind of slaps you in the face like some of those poly photos.
Yeah, that's right.
Right. I mean, it just hits you and says, don't do stupid things.
That's right. A barrier was used where a barrier shouldn't not be used.
Yeah, and you know, again, you brought up a really great point when you talked about the building's ability to breathe, because we always get hammered. We do these videos, people come out immediately, well, houses need to breathe, you guys are all wrong. Exactly. We're agreeing with you. Houses need to breathe from a moisture perspective.
That's right, from permeance.
From an air management perspective, seal it up as tight as you can.
That's right. And then let things permeate through where it's necessary. Steve, great information as always. Really appreciate your support, guys. Go take your quizzes over on thebuildshow.com so you can get a certificate of completion for Build Science 201. With that being said, we'll see you next time on The Build Show.
Sponsored by Anderson Windows and Doors, Huber Engineered Woods, and Proseco. This is Build Science 201.